Welcome. I'm Corn Walker with Proofgeist, and I'm here to talk about loosely coupled with SimpleQ. A little bit about me. I'm a Colorado native who has been held against my will in Massachusetts since 2001. When I'm not hiking, I like to spend my time as a senior software engineer at Proofgeist. So today, I'll be talking about my favorite subject, software architecture patterns, and specifically about developing loosely coupled software using SimpleQ. That title suggests three questions that need to be answered. First, what is loosely coupled software? Second, what is SimpleQ? And third, why would you want to use SimpleQ to help you adopt a loosely coupled development style in your own systems? So let's tackle the first question. Why loose coupling? Before I answer that, I thought I would briefly talk about the problem that led to my search for this solution. One of the first large-scale systems I helped build was for independent schools. There we had systems that shared data and processes that were dependent on each other. For example, when an applicant's enrollment deposit was marked as paid in the admissions system, the applicant should be added to the student system and enrolled into their entering grade. Because various offices are all interested in the new student, there were other processes that needed to happen at the same time. The student needs to be entered into the residential life system so a dorm can be assigned, and the athletic system to check eligibility and notify coaches of a potential new recruit. In addition, the registrar needs to be notified of the new student to schedule them for classes. Just in that one action in the admissions office, we've created a web of dependencies. Here's my vision of how the dependency stack would work for our school administrative software. In my ideal world, all of the dependencies between modules would flow in a single direction, with no interdependencies between modules on different levels. Because all of these flows would be in a single direction, dependencies would be easy to troubleshoot and maintain. However, our vision rarely makes it to reality when it comes time to developing systems. This is what my dependencies actually looked like once the system was under full development. It turns out that when you have tightly coupled systems, your dependencies quickly multiply. If you're not careful, or if the realities of delivery times and budget constraints are such that you need to ship first and fix later, your dependencies can quickly spiral out of control. So going back to that question, why loosely coupled? Loose coupling is a software architecture style in which different apps and services communicate with each other through a simple, well-defined interface. Often, that interface uses a common language, such as XML or JSON, to describe the data being exchanged. In this way, your services don't need to have knowledge of each API consuming the data it provides. Instead, each service needs to understand a simple, universal format and know how to process messages in that format. But I'm getting ahead of myself. The term loosely coupled implies the existence of tightly coupled software, and it's useful to talk about them in contrast to each other. When starting out, most people develop tightly coupled applications without really thinking about it, or because constraints don't allow them time to think about it. So why loosely coupled? In a word, dependencies. A loosely coupled architecture makes sense for a number of reasons. What led me to adopt it was the problem I had managing dependencies that fell largely into three buckets. The first is process or control dependencies. All of those systems become dependent on the admission system to kick off their respective processes when the student is enrolled. But there is a second dependency created, which is that the admissions process needs to be aware of all of the other processes it needs to kick off. If I add another system, say a health system or a cafeteria system, I need to modify the admission system to include those in its post-enrollment process. At the same time, I lose some amount of control over the process in my admission system. Perhaps an error occurs in one of the dependent systems. Are there points where the entire process might abort? What if there are execution errors or runaway scripts, and my admissions process never regains control? There is another related dependency: synchronous execution. In my admissions system example, the enrollment process has to wait until all of the other dependent processes have been completed before control is returned to the admissions system. Frankly, it's not urgent that all of those tasks happen at the very second that the student is enrolled. They just need to be queued up to happen at some point later. Nor is there a business rule that says the admissions process needs to wait until the other processes have completed their tasks before it can continue. So we could attempt to perform those tasks using perform script on server, but that actually introduces yet more dependencies. Finally, when talking about FileMaker systems, there is always the issue of security. In our example, the user running the enrollment process must have their credentials available in all of the systems that are dependent on that process that they initiate. Or those systems need to be able to open with saved credentials. Even with the benefit of external authentication and the more recent addition of OAuth, neither prospect is all that appealing. Mapping privileges to all of the users in interdependent systems is a task that can take weeks to complete. Ask me how I know this. Wouldn't it be great if there were a way to get out of dependency hell completely free? My economics teacher said there ain't no such thing as a free lunch, but he didn't know about free software. There was no free way out, but there was an architecture pattern that showed some promise: loose coupling. As I mentioned before, the loose coupling architecture has a number of benefits. One of the problems with hard dependencies, aside from the task of just managing them all, is that it creates processing delays and potential points of failure. Even the routine act of fixing bugs caused problems that I had tried to solve with regimented scripting practices. But if an API is not working, how do you find all of the places using that API so you can update them if you need to change the API signature or change the API results? Loose coupling won't fix all of our problems, but it will help with some of them. One of the things it does is it helps reduce complex dependencies. Wherever we have dependencies that include multiple items, or where multiple processes have to be executed in a particular way, or have to trigger other processes that in turn trigger other processes, loose coupling can help simplify that system a bit. Loose coupling also addresses service failures. If one service goes offline for any reason, your system can continue to operate because it's not waiting for that process. And finally, loose coupling addresses service change. If you decide to replace a service or an entire system that is part of a complex deployment, in a loosely coupled system, there are only a few points that may need to be updated, or perhaps none at all. As long as the replacement service can deliver or consume the same messages that the previous service did, loose coupling allows you to swap one out and replace it with another fairly simply. However, loose coupling is not a panacea. There are some disadvantages, or contraindications, to loose coupling in your system design. The first is transactional execution. If the multiple components need to all succeed or all fail together, then that's an indication that you need a tightly coupled process. Data duplication can be an issue when using a loosely coupled architecture. The benefit of not having a single data store that every system connects to and is dependent on is that each system can maintain the data in the way that best suits them, usually leading to increased performance as well. However, this can also allow the data to become out of sync, and you'll need well-defined procedures to determine which data is correct at any one point in time. For example, while you may want to loosely couple your main CRM and shopping cart system, and it's okay if a customer updates their phone number in one and it takes a little while to appear in the other, you wouldn't want to loosely couple your sales and inventory processes because you want to know if you have an item available to sell at the moment you are selling it. Generally speaking, if you need all of your data to be up to date to the second, such as in a transactional processing system, you probably want those processes to be tightly coupled. Reliability can be both a positive and a negative in a loosely coupled system. While it's primarily a positive because one service going down doesn't take the entire system down with it, sometimes the user wants to at least be made aware that another part of the system is offline. With loose coupling, we don't always know that one part of the system has decided to go on hiatus because the rest continues working. If the user needs to be notified in real time if any part of the process is down, then that is an indication that you'll want a more tightly coupled process. So what is SimpleQ? It's the solution to all of our problems. It even makes coffee in the morning. What SimpleQ is a FileMaker-based implementation of the publish-subscribe development pattern. It helps manage and coordinate the communication between various processes and services. There are actually a number of different patterns you can use when adopting a loosely coupled architecture. SimpleQ didn't start out using the pub/sub pattern. What we actually did was stumble around a bit, encountering other challenges and trying different solutions, until we landed on one that sufficiently solved the original problem and then some. Before it was called SimpleQ, it actually started out using the observer pattern. Think webhooks. And you can still see traces of that architecture in it today. In fact, SimpleQ is something of a hybrid between observer and publish-subscriber. So pub/sub acts as an intermediary between two systems that wish to exchange information. There are four main concepts with the pub/sub pattern. The first is the idea of a publisher. This is a system or process that is going to notify other processes that it has performed some task or updated some data. It does this by publishing a message, which is the second concept, and it's going to publish that message to a specific channel, the third concept. And the fourth concept is the idea of a subscriber. And a subscriber is another program or process that is going to listen on a channel for any messages that are published there. So a good analogy is the post office. If my electricity supplier wants to send me a bill for services, they could look up where I live, hire a courier to bring the bill to me, wait for me to write a check, and then wait for the courier to return with my payment. Pub/sub is like dropping a post office in between my electricity provider and my house. Instead of needing to know where I live, learning the best way to get there, and waiting for me to finish responding to the bill, the electric company just drops the bill off with the post office, who takes it from there. The electric supplier can then move on to printing up a bill for the next customer. Once I'm ready to send in my payment, I simply drop the return mail off with the post office, who takes care of delivering it to the electric utility. In this way, both the post office and I are exchanging messages with the electricity supplier. This was a nice, neat little analogy until I realized that actually PubSub is like a post office where all of the customers are direct mailers, spamming their advertisements out into the world. But then I realized, oh, actually, at least with PubSub, you have to subscribe to receive whatever is being published out there. So why SimpleQ? There are a number of commercial PubSub services available out there, with some popular options being Redis and Amazon's SimpleQ service. But the problem with them is that they're somewhat inaccessible to most FileMaker developers. SimpleQ was built in FileMaker with FileMaker developers in mind using native techniques. But SimpleQ also works with not FileMaker. With a little more configuration and some web know-how, you can incorporate external services into a modern FileMaker system that shares and consumes data with web technologies. We've been using it internally and are finding a number of ways that it helps the development process, particularly when consuming external REST APIs. It also works with Auto's webhooks receiver, opening up integration opportunities for a number of apps and allowing your app to work as a first-class web citizen. With SimpleQ, you can provide callback functionality to your FileMaker application. Before I go into my demo of SimpleQ, I first wanted to talk about a few things that SimpleQ isn't. SimpleQ is not yet another abstraction layer. It's a part of an approach to architecting FileMaker systems in a way that makes them lighter weight, more portable, and easier to manage. Using SimpleQ, your FileMaker apps work pretty much the same as they do now. What SimpleQ does is allows you to outsource the communication between different processes, so those connections are less tightly coupled where they don't need to be. SimpleQ is also not a task scheduler. While it can defer sending messages until after a certain time, it is not meant to replace FileMaker scheduled scripts, nor is it meant to string together a series of interdependent processes in a strict order. SimpleQ is also not a magic bullet. It won't solve all of your communication or dependency woes. If you want magic, I would recommend checking out GitHub Copilot. So let's take a look at how easy it is to configure and use SimpleQ. I have a little app that I quickly created called Simple Chat. And the idea here is just to have a sort of blank slate to show you how easy it is to add SimpleQ to your system. Here I have my chat topic here, and it's, of course, Mexican street corn. And what I decided was that, in a typical app like this, what I would normally do is if I entered a new message, I would just create that message in the messages table and then refresh the screen. And that's well and good, but what happens if I have a web client that's actually looking at my chat? And I want that web client to actually update as well. Well, I could have the web client periodically polling the database that's in this file to see if there have been any changes. But as we know, on the web, things are much easier and much faster when you can cache that data locally to the web application. So I decided, here's a job for SimpleQ. Rather than create these records here directly, which I'm still going to do, I'm going to publish that message to SimpleQ. And then if I decide that I want a web client later, that web client can use SimpleQ to receive that message. So I'm going to show you here, I'm going to open up SimpleQ. This is the SimpleQ main screen. Again, I'm not going to go into the details of installing, etc. I'm just going to show you quickly that some of the major concepts that we talked about before. The first one being channels. So you can see here that I've created a channel called Mexican Street Corn. One of the things I like to do is to prefix my channel. We use a dot notation in SimpleQ, but here I'm just prefixing it with my application to know that this Mexican Street Corn channel belongs to Simple Chat. The other thing that I do have here are subscribers. So here I've created a subscriber called SimpleChat. That's my subscriber key. And I've got a script here. This is the script that SimpleQ is going to call in my file whenever it has a message to deliver. Next, I have my message queue. My message queue is a list of all of the messages, including the statuses for whether they've been sent or not. If SimpleQ is unable to deliver the message for whatever reason, it can fail permanently with an error 2. If the message is newly created and SimpleQ simply hasn't tried delivering it yet, we've got a code of 0, a status code. And if the message has been delivered, you can see a status of 1. So if I go back to my app over here, I'm going to enter in a new message. And here's what's going to happen. Let's see. So when I sent off my message, what happened here is it actually ran a script in my file. And my add message script here. And instead of creating the record directly, what I did was I actually packaged that up to send off to SimpleQ. SimpleQ just requires a couple of parameters. The first is the payload. And this is going to be what actually gets delivered to all of the subscribers of the channel. And the second is the channel itself. So again, in my case, what I'm doing with my channels is I'm taking the channel name out of my chat application and I'm prepending it with the subscriber key, which is SimpleChat, just so that I have something that's unique there. And so I create a parameter that has those two elements, and then I call this publish message script that's over in SimpleQ. And that's it. Now when SimpleQ gets that message, you'll see that it shows up here as a new message with that status. Now normally what happens is you would have a script scheduled on your FileMaker server that periodically flushes the queue. In this case, I'm going to go ahead and trigger a manual flush of that queue by clicking this retry button here. And you can see now that that message was delivered. If I go back over to my SimpleChat system, you'll recall that SimpleQ receiver script that I had configured. And what happens is that payload that SimpleQ got is just being pushed right back to my app, to this script, which I get as the script parameter. And then I decide that I'm going to handle that payload with my receive message script. And if I look at receive message, it does what it would have done before, which is to take that payload, decompose it into its elements. And again, here is why we use JSON. JSON makes it really easy to pass things back and forth with an encoding standard that is native to FileMaker. So I go ahead, I create the message, I enter all of the information, complete it, and close it. And now, if I go back to my SimpleChat, I should see that message has shown up here. And that's pretty much it for SimpleQ. Again, now, if you wanted to see those scripts here, I actually got those scripts from my SimpleQ file itself. So that SimpleQ receiver is a script that you can copy into your file. There's also other scripts where you can copy the steps into your file if you want to automate some of these things. So rather than creating the channel manually, you can actually do that with a script where you just set up the channel name and you call create channel in SimpleQ, and it'll create that channel for you. Same thing with subscribing to a channel. And then also you can see here when I published to a channel, when I created my message, these were the script steps that I had copied into my file to be able to do that. Now that I've hopefully sold you on the idea of SimpleQ and shown you how easy it is to integrate into your own systems, the good news is that SimpleQ is available today, and we've even written some pretty good documentation on it to help you get started. Simply visit our website at simpleq.proofgeist.com, where in addition to that documentation, you'll also find a short overview video and links to the software. If you want to skip that step and just dive into the files, you can also get SimpleQ from our GitHub repository, where we will post future releases. If you download a copy and have feedback, please drop us a line letting us know what you think. SimpleQ has become an essential component in our modern FileMaker toolkit, and we hope it becomes a part of yours as well. Thank you.